Hello everyone, welcome to my YouTube channel Telugu Allrounder. In today's class, I will explain about the topic Introduction to Algorithms in the subject of Design Analysis and Algorithms. This is my first video. All of you, please like, share, subscribe my channel. Algorithm. What is algorithm? A algorithm is a step-by-step process to solving a problem is called algorithm. It is a step-by-step process solving a problem is called algorithm. It is a called algorithm. Okay. We can also give one more definition is set of instructions that are carried out to solve a problem is called algorithm. Set of instructions that are carried out in order to solve a problem. In order to solve a problem is also called algorithm. Generally, we will discuss, for example, preparing a Maggi. Okay, what are the steps to prepare the Maggi? Okay, when you want to eat Maggi, we need to follow some basic steps. What are the steps? First step is we need to purchase Maggi packet and we have to return back to the home. And what is the third step? Turn on the stove and place the pan. Next one is pour some water inside the pan. Next step is place or throw Maggi inside the pan. Next step, after 5 to 10 minutes, water boiling, add your Maggi content and also boil 2 to 3 minutes. And next step is after 2 minutes, you have to add Maggi masala inside the pan. Again, you have to boil the content minimum 2 to 5 minutes. In next step, the Maggi is prepared. Okay, these are the steps we have to follow to prepare Maggi. Okay, so these all steps are called algorithm. These all steps are called algorithm. Okay, next, what are the common terms? Common terms in algorithm. Generally, there are three common terms. What are the three common terms is? First one is variables. What is variable? A variable is nothing but it is a memory location. It is memory location which stores only one value. Only one value. It means what? It is a memory location. It can store only one value at a time. Suppose if you want to store another value, the previous data will be overridden. Okay, it can store only one data, only one value. The next common term is data type. What is the meaning of data type? Data type is nothing but it specifies what type of data we are using in programming. What type of data we are using. It means what? It specifies The type of data we are using, the type of data we are using. Okay, you know what is the data types we have? Integer type, float, character, etc. These are the different type of data types. The next one is statement. What is the meaning of statement? Statement is nothing but it is a just line of code. What the meaning of statement means? Set of instructions or line of code is called statements. Line of code is called statements. Next, we will discuss about what is properties of algorithm. Properties of algorithm. Okay, generally every algorithm contains some basic properties. What are the properties we have? The first property is input. What is the meaning of input? The algorithm uses some input data. This input data is called input. This is the input. Okay, here algorithm uses values from a specific set. A specific set. For example, a set of values. For example, it is a set A. Here, A contains some values. If the algorithm using these values, this is the input of the algorithm. Okay, every algorithm must contains 0 or more inputs. 0 or more inputs. Okay, next property is output. What is the meaning of output? Based on the input, the algorithm produces the output for every input value. What are the producing? Those what are the producing result is called output. What is the meaning of output means? Based on input values for each input produces output. For each input produces output. Okay, the next property is correctness. What is the meaning of correctionness? Sorry, correctionness. What is the meaning of correctionness? Means here the output is corrective or not. Okay, it will checks the property checks the output is correct or not for each and every input in the defined problem. Okay, here output sorry input is defined for that output is correct or not. Correct or not. Okay, next property is finiteness. What is the meaning of finiteness means? Here the finiteness, this property checks algorithm giving the output in limited steps or not. Okay, for example, you are solving a problem. Okay, the problem has to give the result in limited steps. Okay, if it is not giving the limited steps, that is not good for, that is not a good algorithm. Okay, same here also, when you are solving any problem, it has to give the result in limited steps. Suppose if it is taking large number of steps, then there is a no use of that particular algorithm. Same here also, finiteness means algorithm has to give, algorithm produces output after finite or limited number of steps for each input. This is called finiteness. Okay, next one is determination. What is the meaning of determination? Determination is nothing but after number of steps, result should be guaranteed. Okay, suppose you are solving a problem with a number of steps, but you are going to the steps are going, but the result is not producing. Then there is no use. So here, what is the meaning of determination means after some steps, the every algorithm has to produce the output. That is called determination. After steps, result should be guaranteed. That is called determination. The next property is generality. What is the meaning of generality means procedure following to entire problem or part of a program. Okay, here generality means the procedure, whatever the procedure we are applying, procedure applied to all parts, all the problem, not a specific subset. It has to apply to the all the problem. The last one is program. What is the meaning of program? Program is implementation of the algorithm using any one programming language like C, C++, Java, etc. These all are the properties of the algorithm. What are the properties we have? Input property, output property, correctness, finiteness, determination, generality, program. These all are the properties of the algorithm. Next one. The algorithm can be expressed in different notations. Okay. Generally, every algorithm can be expressed in different notations. Algorithms can be expressed in different notations. What are the different notations we have? The first one is we can write the algorithms in our natural languages. Okay, natural languages. Natural language means what? Our general languages. Okay, next one is pseudo code. We can write algorithms in pseudo code. Okay, next one is flowchart notation. What is the meaning of flowchart notation? Flowchart is nothing but what? Flowchart is nothing but a pictorial representation of the algorithm is called flowchart. What is the meaning of flowchart? Flowchart contains diagrammatic. Okay, this type of diagrams are there in flowcharts. Okay, this is called pictorial representation of the algorithm is called flowchart. The last fourth notation is programming languages. What is the meaning of programming languages? We can also, it means we can write an algorithm in our regular programming languages like C, C++, Java, Python, etc. Okay. Okay, this is about today's class. Okay, if you have any doubts in this class, please ask your doubts in comment section. But don't everyone should everyone has to please like and subscribe our Telugu All-Rounder YouTube channel for upcoming classes. Okay, thank you everyone. Hello everyone, welcome to my YouTube channel Concept Clear. In today's video, I will explain the topic is performance analysis in the subject design and analysis of algorithms. Okay, what is performance analysis? Very simple. Generally, what is meaning of performance analysis means calculating the calculating performance and comparing with others. Okay, same here also. What is meaning of performance analysis means how efficiently an algorithm is working compared with another algorithm. Compared with another algorithm which solves the same problem. Here both will be solve the same problem. whenever executing, whenever solving a problem with two three different algorithms, which one is the best one? That is called performance analysis. Okay, for example, here you want to purchase a bike. Okay, you want to purchase a bike. Okay, here there are two bikes. You want to purchase a bike. There are two options, two bike options we have. Okay, what are the two options? One bike is giving 50 kilometers mileage, another bike is giving 55 kilometers mileage. And if you see the other pictures, the same price and same color, same features and same handle. Okay, all are same. Now, which one you will purchase? Which one you purchase? When you are having here, we choose the second bike. Why? Because what is the reason for second bike? Choosing the second bike is it is the giving 55 kilometers mileage. It is giving 55 kilometers mileage because it has more efficiency here. Second bike contains more efficiency. So we will take the second bike. Okay, same. When you having two algorithms, which one is solving the same problem in less time? In less time. That is the best algorithm. Which one is taking more time? That is the which one is giving the uh, less time and more efficiency. That is the best algorithm. Another one is the here by using the performance. Oh, sorry, by using the performance analysis, what you will calculate? You will calculate efficiency. We will calculate the efficiency by using performance analysis. We calculate the efficiency. We calculate the efficiency and how the efficiency will be calculated. How the efficiency will be calculated. Generally, the efficiency will be calculated two ways. What are the two ways means? The first one is time complexity. Okay, generally we can calculate the efficiency by using two ways. The first one is time complexity. What is the second one is space complexity. Okay, we will see what is time complexity, what is space complexity. Okay, what is time complexity? Time complexity is nothing but how much time is required to complete a program or algorithm execution is called time complexity. Okay, see here, the amount of time an algorithm is required to complete its execution is called time complexity. What do you mean of time complexity means? Suppose you are executing a problem or an algorithm, how much time is required? That is called time complexity. Generally, the time complexities are three types. What are the three types means? The first one is best case, worst case, average case. What is the meaning of best case time complexity? Okay, what is the meaning of best case? If an algorithm taking very less time, okay, if an algorithm taking very less time, then it will be called what? That is what called as a best case. What is the meaning of best case? It takes minimum amount of time. Minimum means what? Very less time. Then it is called best case time complexity. And what about worst case? Okay, best means minimum. What about worst case means? It is maximum amount of time. If an algorithm or a program will take maximum amount of time, then those algorithm is called worst case time complexity. And what about average case? Average case means what? It means it is not a minimum as well as it is a not a maximum. So what is the meaning of average? Average amount of time. If an algorithm taking average amount of time, then we are called as a average case time complexity. Okay, here what is the best means? We can also call as what? Less time. It takes the less time. Worst case means high time. Okay. Here we can't calculate the time complexity in the seconds. Okay, we can't calculate the time complexity in the seconds. Wait, I'm writing here. We can't calculate time complexity in seconds or minutes. Then how we will write? We can it can be measured. It can be measured it in order of n. That means what? You can write O of n. Okay, the time complexity we can't calculate in the time, seconds or minutes. How we can calculate means you can calculate order of n. You can also write like O of n. O of n. And so here I will explain. There are two type of the time complexities again. What are the two type of time complexities means? First one is constant time complexity. What is the meaning of constant time complexity? Generally, the name only constant means what? It means the time required is constant. It means what? If you are executing a problem with different input values, for every input value, it has to take the same fixed amount of time. Okay, based on the input values, the time is changed. Then it is called what? Then it is not a constant time. If you take whatever the input values, it has to take the same time, that called constant time complexity. See here, if required amount of time is it requires fixed amount of time for all input values, then it is called what? Then it is called constant time complexity. See here one example. Here I am writing here int sum of int comma a. What meaning of int comma a comma b? These are the two parameters I have taken as a variables. Okay, if you are performing a equals to b. For example, I am taking here a value 3, b value 5, and what about return value? Return value is 8. How much time is taken? Same. If you change the a and b value like 1000, 2000, then also it has to take the same fixed amount of time. Then it is called constant time complexity. Okay. Next, what about linear time complexity? Linear time complexity is nothing but if input values are increasing, then the time complexity also changes. What the meaning of linear means? Based on input values, time complexity will change. Okay, the meaning of linear means based on input values, the time complexity will be changed. That is called linear time complexity. Linear time complexity. Okay, this is about the time complexity. Now we will see what is space complexity. What is space complexity? Generally, to perform any algorithm execution or program execution, we require what? We require memory. What is the purpose of the memory means? To store the variable data, we require the memory. Okay, here what is the meaning of space complexity means? Amount of space an algorithm requires to complete execution is called space complexity. Here, what is space complexity means? Very simple. You are executing a program, you are executing an algorithm. In that algorithm and that program, we have some variables. Okay, to store the variable data, we require the memory location. So, how much space is required to store the data to complete the program execution or algorithm execution? Okay, the required amount of space is called space complexity. Okay, here there is a formula S of P equals to C comma SP. What the meaning of C means? C is the constant value. C is the variable and S of P is other variables. Okay, here we will see what is the meaning of S of P. S of P is nothing but space complexity. And what about C means? C is nothing but constant or independent variable, independent part or a variable. And what about SP means? SP means dependent part or variable. Dependent part and dependent part or variable part. Okay, here we will see one example algorithm. What is the example here? Algorithm for sum of two numbers. Okay, very simple algorithm. Okay, see here I am taking the algorithm algorithm sum function. Here I am taking three parameters. What are the three parameters is A, B, C. Okay, inside the loop I am writing A. I am considering A equals to 1, b equals to 2, c equals to a plus b. Now I am closing the algorithm. Okay. Here, what is the formula here? We have formula is s of p equals to c plus sp. Okay. Here, what is the constants? Here, a is the constant value, b is the constant value. So, I am taking the constants are three constants. What are the three constants? 1 plus 1 plus 1. Okay. C is also constant. So, 3 ones plus what is the sp value? We don't have any sp value. So, we are not taking any sp value. Next. What is the, if we calculate these all the three values, we are getting 3. Okay, what is s of p equals to? S of p equals to 3. It means what? When you are getting s of p equals to 3, here we have to write, it is a constant value. When you have getting constant value, we have to write order of 1. Order of 1. Okay, here 3 means order of 1. And what about 100? 100 also order of 1. And what about 1000? 1000 also order of 1. Okay, if it is a constant means we have to write order of 1. How we will write means order of 1. It can also write O of 1. O of 1. Okay, suppose it is, if it is not a constant, okay, here we are getting the constant, then we are getting writing the order of 1. And if it is not a constant means, if it is not constant value, then we have to write n square, like that. We have it will like that. We have to write the time space complexity n square, like that. Okay, guys, this is about today's class, performance analysis. Okay, in the performance analysis is nothing but what? Performance analysis is nothing but calculating the efficiency of the algorithm when you are solving a same problem with multiple algorithms. That is called performance analysis. Performance analysis. We have two types. The first one is time complexity. The second one is the space complexity. Okay, I hope you all are understood my class. If you have any doubts, please message me in the comment section. All of you, please subscribe our YouTube channel, Concept Clear, and subscribe and also share with other college students. Okay, thank you. Hello everyone, welcome to my YouTube channel Concept Clear. In today's video, I will explain the topic of asymptotic notation in the subject of design and analysis of algorithms. Okay, first we will see what is asymptotic notations. Asymptotic notations are nothing but it is used to calculate the time complexity of the algorithm. Okay, we can also say it is an way to representing the time complexity of the algorithm. The way means it is nothing but it is a mathematical way representing the time complexity of the algorithm. Generally, there are 5 types of the asymptotic notations. Those 5 are the big O notation, big omega notation, theta notation, little o notation, and little omega notation. According to J2H, we have only 4 notations. These 4 are the big O, omega, theta, and little o. But little omega is not in the J2H syllabus. Okay, in this video, we will discuss each and every topic very clearly. Okay, if you see, the first one is big O notation. What is the meaning of big O notation? Big O notation is mostly used for representing worst case of time complexity. Okay, it is mainly used for calculating the worst case time complexity. Here we will consider the upper bound value only. What is the meaning of upper bound value means maximum amount of the time. Okay, see here. It is used to representing upper bound of algorithm runtime, and by using big O notation, we calculate the maximum amount of the time. What is the maximum amount of time means? If you are taking the maximum means what? If you are taking the much time means it is the worst case. So here we calculate the maximum amount of time of the an algorithm it requires for execution. It means what? Worst case time complexity will be calculated by using big O notation. Okay, it is frequently used notation. Why? Because it is frequently used means, suppose if you are it covers the minimum best case time complexity as well as the average case time complexity as well as the maximum case time complexity. If any algorithm taking much time means it will calculate the minimum, average, as well as the maximum. Okay, here we will see the graph. Here are the g of n function always grows faster than f of n function. Here, see, the f of n is a function and g of n is a function. These are two functions are used to calculate the time complexity. Here, f of n equals to big O of g of n. What meaning of O means? It is a big O. Okay, why? Because big O means it is a big O notation. Big O of n. Okay, then according to our big O notation, the equation is f of n is less than or equals to g of n. See, here according to the graph, f of n is lesser than to g of n. So by comparing the graph, we can say this one. Okay, finally, we can also write f of n less than or equals to, instead of O, we can write c means constant value. C means constant of g of n. Okay, we have to derive this one. For example, I am taking here f of n function is a 2n square plus n. We need to find time complexity. What is the meaning of time complexity? Means how much time is required to calculate, how much time is required to execute a algorithm. The time is called time complexity. Okay, in order to find, we need represent of the in the terms of g of n. Here we have to find f of n equals to order of g of n. Oh, so here we need to find out the g of n. Okay, in order to find out, we need representing the in order of, in terms of the g of n. Here, in the place of f of n, I am writing here 2n square plus n less than or equals to, what is the formula here? The formula is f of n less than or equals to c dot g of n. So here I am writing 2n square plus n less than or equals to g dot, we don't know what is the n value. So generally in terms of, if we don't know what is the g of n, we will take n square. Okay, 2n square plus n less than or equals to c dot j n square. If you 2n square plus n less than or equals to, instead of g, I am writing here directly cn square. Okay, let's check for which value will be satisfied. So I am checking here c equals to 1. So what happened? If you are taking the c equals to 1, 2n square plus n less than or equals to 1 into n square. So the equation is not true. So we are considering next one. What is the next one? C equals to 2, 2n square plus n less than or equals to 2n square. It is also not true. Okay, next 2n square plus n less than or equals to 3n square. If you perform the calculate, the equation will be this condition is satisfying. So this condition is satisfying. This is true. And what about next one? If you try c equals to 4 also, it is true. Okay. And what about c equals to 5 also true. If you check c equals to 6 to up to n, all the statements are true. Okay. Here we have to consider least upper bound value only. Okay. In big O notations, we will calculate the upper bound value. In that also, least upper bound value. Okay. So here we are taking the least upper bound value for big O notation. Here the first condition c equals to 1 is false, c equals to 2 is false, c equals to 3 is true. And what about 4 and 5? These all are true. So in these 3, 4, 5 up to n numbers, what is the least upper bound value? 3. So we have to consider c equals to 3 only. Okay. Now what is the equation for, if you are implementing c value 3 means, what is the equation? 2n square plus n less than or equals to 3n square. That means what? That means if you send this 2n square this time, here we will get the minus value. So n square, n less than or equals to n square. So if you are performing calculations, n by n less than or equals to n by n square plus n. So we will get finally 1 less than or equals to n. Okay, which is nothing but n less than or equals to 1. So what is the final value? 2n square plus n less than or equals to 3n square is true for all n greater than or equals to 1 value. Okay, it is true for all n greater than or equals to 1 value. Okay, this is about the big O notation. Okay, after discussing big O notation, the next notation is omega notation. What is the meaning of omega notation? Omega notation is a notation. It is used to calculate the lower bound value. Okay, in the lower bound value. In the lower bound also, it will calculate the, use it to calculate the greatest to lower bound value. Okay, not only lower bound value, greatest to lower bound value. Okay, listen. Here, omega notation used to calculate the lower bound value. It means the minimum time complexity. What is the meaning of greatest value? If you have 1, 2, 3, 4. Okay, in this 1, 2, 3, 4, what is the least greatest value? Least greatest value is the 1. So, we will then what is the minimum value means it is the best case values. Okay, it represents best case time complexity. So, what is the equation we can say? F of n is equals to omega of g of n. F of n equals to omega of g of n. And if we can also write like f of n greater than or equals to c dot g of n. Okay, if you see the graph here, the f of n is always goes faster than g of n. See, f of n greater than or equals to g of n. So, according to this, the graph also always grows faster than by comparing g of n. Okay, next, if you are taking same example here also, f of n equals to 2n square plus 2. That is the f of n value. I am taking here g of n equals to n square. Okay, here we are finding the lower bound of f of n. Okay, if you are implementing here, if you are implementing this equation, what do you get? 2n square plus n greater than or equals to c dot, what is g of n value equals to n square. So n square. So same as the previous derivation. Here also you have to check c equals to 1. If you are implementing c equals to 1 means the value is 2 plus 1 greater than or equals to 1. So it is the condition is true. Okay, and next one is 2n square plus n greater than or equals to, if you are implementing 2 equals to means it is also true. Okay, in first two cases are true. Next, what about third one? If you are implementing c equals to 3, it is becomes false. It is not true. Okay, and what about 4? It is also, if you are implementing 4 also not true. So among c equals to 1 and 2 are the satisfied. Okay, and what about c equals to 2? Here 1 and 2 is that true, and what about 3 is false, and what about 4 also false. And if you take up to n numbers, these all are the false. So we have to consider what? We have to consider 1 and 2. Among these two, what is the least greatest value? Among these two, the least greatest value equals to c. Least greatest value is, sorry, among c equals to 1, c equals to 2, we need to c equals to 2 only. Why? Because we are considering least bound, in that also greatest to lower bound value, latest to lower bound value. So if you are substituting c equals to 2 in this equation, what you will get? 2n square plus n greater than or equals to 2n square. It is the, you have to substitute here. Okay, according to n value have to substitute. So f of n 3n plus 2 g of n equals to n. So if you calculate this, finally you will get the c equals to 1 is satisfying, and also finally we will get 3n plus 2 greater than or equals to n. Here it represents what? 3 plus 2 equals to omega of n. Okay, this is about the omega notation. Okay, next notation is theta notation. Is the third notation is theta notation. And what about theta notation means? Theta notation is nothing but is a combination of big O notation as well as the omega notation. Okay, it is the combination of big O notation as well as omega notation. Why I am saying that is a combination means, here we will calculate the average bound. Average bound means what? It is the combination of lower value as well as higher value. So theta is a combination of these two. Okay, it represents average bound of the algorithm runtime, and it means what? It gives the exact time. If it is average means what? If you are providing the lower means best value, if you are giving the maximum means worst value, and if you are providing exact value means the average exact time will be provided by using the theta notation, because we are considering average case time complexity only in theta notation. It represents with theta symbol. It represents with theta symbol. Okay, if you are what is the equation for this? Equation is c1 dot g of n less than or equals to f of n less than or equals to c2 dot g of n. Here c1 means first constant value, c2 means second constant value. And what about graph? Here graph also have c1 and c2. Okay, here the always c2 is growing faster than C1 g of n function, f of n function. Okay, see here g of n equals to n square, f of n equals to n square plus n. Okay, we are taking the same example. Okay, if you are writing this equation, if you are implementing here these two in this equation, we will get c1 dot g of n less than or equals to, so here we have to write c1 dot n square less than or equals to 2n square plus n, c2 dot n square. If you provide the derivation for this one, in this previous example, we are getting c1 equals to 2 is satisfying, and this side c2 equals to 3 is satisfying. So I am not doing again and again here. So here theta notation will be satisfies for this equation where c1 equals to 2 and c2 equals to 2, c2 equals to 3. Okay, this is the best to this is the way we have to calculate the theta notation. Okay. Okay, next two notations are very simple. These are the little o notation as well as the and also little omega notation. Okay, what is the little o notation? It is very similar to big O notation, but in big O notation we are considering least upper bound value, but here we will calculate only upper bound value. Okay, it is similar as the little o notation. In that we are calculating least upper bound value. Here we will calculate only upper bound value. Formally, what is the equation for this one is f of n equals to order of g of n. F of n equals to order of g of n. Okay, I am not doing any derivations here. You need to provide the derivation in exam. Okay, so what is the equation? What is the example I am taking here? 2n square plus n less than 3 dot n square. Okay, we have to provide the derivations for this one. C equals to 1, C equals to 2, C equals to 3, up to where it satisfies. Okay. Okay, and the last one is little omega notation. What is the meaning of little omega notation? It is also similar as omega notation. In omega notation, what we are considering? In omega, we are considering lower bound value. Lower bound. And not only lower bound, in the lower bound also we are calculating the greatest to lower bound. Greatest to lower bound. Okay, but what about here? In little omega, we will considering greatest lower bound value, we will consider only lower bound value of f of n function. So what is the equation here? There is no need to write the symbol of less than symbol. So what is the equation here? No equals to symbol, only we are using the greater than symbol. So what is the equation here? F of n equals to omega dot g of n. Omega dot g of n is the equation. Okay, again here we need to provide the c1 value, c2 value, up to where it will provide, where it will be satisfied. We have to check. These are the 5 notations of asymptotic notations. Okay, what are the asymptotic notations means? The first one is asymptotic notations are nothing but used to calculate the time complexity. Okay, I hope you all are understood my lecture. Okay, please like, subscribe our YouTube channel and also share our video with your classmates and other college students also. For more videos, subscribe our YouTube channel. Concept clear. Thank you all. Hello everyone, welcome to my YouTube channel. In today's video, I will explain about divide and conquer rule topic in the subject of DAA. Okay, now see what is divide and conquer rule. Divide and conquer rule is one of the important strategy for solving problem. Okay, it is one of the algorithm solving strategy. Here, what is the main concept here? Here, we have to divide something, also we have to divide a problem into some small parts, and we have to provide the solution, and after that again all the small parts will be integrated as a single part. Okay, that is the divide and conquer rule. We will see steps. What is the first step? Here we have only 3 steps. The first step is divide the problem into small parts. The first one is divide the problem into small parts. The second step is after dividing, independently solve the small parts. We have to solve the each sub problem. First here the problem is divided into sub problems. Okay, here also sub problem, here also sub problem. Then after that we have to provide the solution and solution. What about the third step is combine these solutions to get overall solution. So what is the third step is combine. So what is the problem here? Divide and conquer. It contains the only three steps. The first one is divide the problem into small subparts. The second one is independently we have to solve the small parts. The third one is combine these solutions to get the overall solution. We will see one diagram here. Here is the problem size n. Okay, suppose the given problem size n, then the problem is divided into multiple subparts. Okay, this is the first subpart. So here what happens? Suppose you are dividing the problem in three parts, means the first subpart is subproblem 1 size is n by 3. Subproblem 2 size is n by 3. Subproblem 2, 3 and size is n by 3. Why? Because we are dividing into three subparts. Okay, so first one, second one, third one. Okay, then what is the next step? First step is divided. Okay, it is the part for divided. Okay, next, what about this one here? We have to provide the solution. We have to provide the solution for each subproblem. We are providing solution. Okay, it is called, what about this step is called divide and conquer. This is the conquer. And what about the last step? Here we are combine the problems. All the individual solutions will be combined here to get overall solution. Okay, here there is an algorithm for this one. What is the algorithm here? Here, divide and conquer algorithm of P. Here P is nothing but passing a problem. Okay, here P is nothing but a problem. Okay, P as a passing as an argument in this algorithm. So divide and conquer. Okay, next one. If small of Pij, then what is here? Here the problem is small. Then no need to break. Okay. If it is the problem, given problem is small, then no need to break. Simply provide the solution. Else, okay, if the problem is, if suppose this condition is true, then simply provide the solution for small of p. Okay. Else, if this condition is false, then the else part here, divide the p into p1, p2, p3 up to n problems. Okay. What is the p here? P is nothing but what? P is nothing but problem. The problem is divided into multiple subparts. Then what is this is the first step. Okay, step 1. Okay, what is the second step? Apply the solution. So individually you have to provide the solution. So apply the divide and conquer rule. Again the same method you have to apply here, divide and conquer rule. Okay, here I have to provide the solution for divide and conquer rule. Apply I have to for problem 1, problem 2, problem 3 up to n problems individually. And what is the next step? Combine all the problems to make overall solution. So this one and this one and up to and under all the subproblem solutions are combining here. So to get the overall solution. Now, this is about divide and conquer rule concept. And here divide and conquer rule contains some applications. What are the applications means? The first one is binary search application, quicksort application, midsort application, Strassen's matrix multiplication, and finding maximum and minimum application. Okay, in our syllabus we have these 4 applications, but this is one finding maximum is not in our syllabus. Okay, if you like my lectures, please like, share and subscribe our YouTube channel. Thank you everyone. Hello everyone, welcome to my YouTube channel. In today's video, I will explain about binary search algorithm using divide and conquer. Okay, here what is meaning of binary search? Binary search is the one of the application of divide and conquer strategy, and the binary search is the efficient for searching sorted array. Okay, it is only efficient in the sorted array. What is meaning of sorted array means the elements are in ascending order or descending order, whatever it is. Okay, and we will see what is the algorithm. The algorithm, the first step is the find the middle of the item of a given array. Suppose if you take any list of arrays, if you take any array elements, we have to find out the middle of the array. So here it is the array. Okay, assume it is the array. Starting of the starting side, and this is the ending side. Okay, first we have to find out the middle of the array in first step. For the second step, find the middle of the array for n by 2. For example, here if I divided the 2 parts, means this is the n by 2 and it is the n by 2. Again, for the second step, find the middle of the array in the, again this part we have to find out the array. So then it becomes n by 4. Okay, again step 1 and step 2 have to repeat multiple times until we are getting lower bound becomes upper bound value. Lower bound value becomes to upper bound value. Okay, here only first step is find the middle of the item of the an array size n. Then find the middle of the array of size n by 2. Okay, then it becomes n by 4. Same these steps, these two steps have to repeat multiple times up to lower bound value becomes upper bound value. Okay, here when you are doing so okay, here we will see one example, one algorithm. What is the algorithm here? Binary search algorithm. A is array name, n is a number of elements, key means searching element. Okay, here start equals to 0, end equals to n minus 1. Okay, array of the elements. Okay, next, while start is less than or equals to end aithe, then we have to find out the middle element. What is the middle element? Start plus n by 2 equals to 2. Okay, here start by n by 2 means not the element values. We have to take index values, array index values. Okay, array index values. If key is equals to mid aithe, okay, if key value is equals to mid aithe, then return middle value. Okay, then return middle element, then return middle element, then return the middle element. Else, if key less than of a of mid, then if key value is equals to a of mid, suppose this condition is true, then we have to move to left side array. We have to move to left side array. Okay, we have to move to left side array. If you move to left side array, then what happens? The middle element becomes what? The middle element will be removed. Before the middle element, that becomes the end element. So end equals to mid minus 1. Else, suppose this condition also false, then what is the condition? Key greater than or a of mid means, suppose these two conditions false, means what is the step will be true? This condition will be true. Suppose this condition is true, then start equals to mid plus 1. Very simple. If we are finding here middle element, suppose here key equals to mid means return mid value, have to middle return will be middle. Okay, if key is greater than mid, ante key value is less than mid, ante suppose the key value is in this part, we have to move to left side. Okay, this is the first condition. The second condition, we have to move to left side. And suppose what is the third condition? If key is greater than mid, then right side we have to move, right side. Okay, what about remaining part? When you are moving left side, the right side part will be deleted. Suppose if you are moving the right side, the left side. Suppose if you are moving left side, right side part will be deleted, and if you are moving right side, then left side part will be deleted. Okay, same process will be repeated up to the lower bound value becomes upper bound value, up to upper bound value. Okay, here we will see one example. What is the example here? Here I am taking list of arrays. Here I am taking list of arrays. This is the starting element, this is the ending element. Okay, here for this given array I am taking the index numbers 0 to 9. Okay, here what is the elements? Totally we have n equals to 10 elements. E is 59. What is the 59 means? Searching element. Searching key is 59. Searching key is 59. We have to search 59 key. Okay, what is the first step? Find the middle of the array. So what is the middle of the array means? Mid equals to start plus n by 2. What is the mid means? What is the starting element is 0. Ending element is 9. So 0 by 9 equals to 2, that is 4.5. We will consider it is 4. Next, I have to check the condition. What are the three conditions? First, we have to check a of mid equals to a of 4. So here, what is the fourth element? So what is the mid element here? Mid element is 25. So here we need to check three conditions. In the algorithm, I told that already. I have to check the three algorithms. So same algorithm here. We need to check three conditions. What are the three conditions means? First one is key is equals to mid, then directly return the mid value. Okay, that is the first condition. Okay, so what is the second condition? Key less than mid, then end equals to mid minus 1. End equals to mid minus 1 means we have to move left to side. We have to move left to side. Okay. Then the third condition is, if these two conditions are false, the third condition is key greater than mid. Then move. Then start equals to mid plus 1. So it is right side. Okay, right side. Okay. I have to check these three conditions. Okay. Here, what happened here? Key greater than mid value. So what is the key here? 25. The switching limit is 59. So KE 59 greater than 25. The condition is true. So we have to move to right side. We have to move to from middle value to right side. We have to move. Okay, when it becomes the middle value, have to put it as the middle. Okay, have to move right side, and this left side part will be deleted. Okay, next. So what is the array here? This is the required array. Okay, again same process. Starting, this is the start element, this is the end element. Again we have to find out the middle value. How to find out the middle value? Mid equals to 59 by 5 is the starting element, by ending element by 2 equals to 14 by 2, that equals to 7. So again this becomes the middle value. Okay, this becomes the middle value means what? Again we have to check these three conditions. What is the conditions here? Here key less than middle value. Key is the less than the middle value. What is the key value? Is 40. Key value is 59. The middle value is 63. So if we compare, key is 59 less than 69. The condition is true. So what I have to write? End equals to mid minus 1. So this part will be removed. This part will be removed. Only these two will be considered. Okay. Middle value, these two are the removed. Only these two will be considered. So this is the latest start. Okay, here 5, 6. Okay, index numbers 5 and 6. The elements are 49, 55. Okay, again what I have to do? We have to find out the middle value. So here, what is the middle value? Middle equals to start plus end by 2. That equals to 5 by 6 is equal to 5. So again, it is the start, it is the end element, and it is the middle element. So middle equals to what? Middle equals to 5. So what is the element here? 45. So again, I am checking three conditions. Array of mid equals to 45. Okay, the condition is what? The condition is array of mid equals to 45. The condition is false. So key greater than mid. Key is greater than mid. So the second condition is true. So the second condition is true means what? We have to remove this part. We have to consider only this right side. Okay. Next here, start equals to mid plus 1. So immediately 5 plus 1 equals to 6. So we have to select this one. Okay. After that, what is the latest array here? The latest array is 59. Again here, this is the start element, this is the end element. Again we have to find out the middle element. Middle element equals to 6 by 6 equals to 6. So here what happened? Here array of mid equals to array of 6. So what is the value here? 59. So the condition is the searching element has founded at the middle element. So here key equals to middle. Here key equals to middle. Then return mid equals to 6. Then what happened to? Then we have to return middle equals to 6. So the searching element is presented at 6th position in the given array. The searching element is presented at 6th position, at 6th index position. Okay, again here we have to club all the at 6th position. Hello everyone, welcome to my YouTube channel. In today's video, I will explain about the topic is quick sort using divide and conquer in the subject of DAA. Okay, coming to our topic, in last class we seen about what is divide and conquer rule and what is the first application of divide and conquer rule is binary search. In today's class we will discuss about quick sort. What is quick sort? Quick sort is the efficient sorting algorithm to comparing other binary search methods. Okay, quick sort is the one of the efficient sorting algorithm. Okay, how it is works? It is based on the divide and conquer strategy. It is based on the divide and conquer strategy. It is based on divide and conquer strategy. Here, what is the first thing here? The arrange the array elements in array elements. Okay, next one. First we have to apply partition algorithm for the array elements. Later we have to apply the sorting technique. Okay, here partition of the array, how it will be completed means, first left side element and right side element. Then this partition is, once the partition is done with the help of the an array is called, element is called pivot element. Okay, here the partition will be done with the help of the pivot element. Okay, after finding pivot location, then it is easy to divide the array into left side part and right side part. Okay, after selection of the pivot element, we need to repeat the same procedure until partition contains only one element for both sides. Okay, suppose this is the element. First you have to find out where is the pivot location. Once if you find out the pivot location, we have to split the array into two sides. Again the same procedure we have to implement for finding the for quicksort arrangement. Okay, we will see example here. Okay, before seeing the example, we will see what is the algorithm steps. Okay, what is the first step is find the pivot element that divides the array into two parts. Okay, in this example, we have to find out the pivot element. We have to find out the pivot element. What is the second step? Quicksort left side of, that is the second step, and quicksort the right side of. It means what? The same first step we have to repeat and up to finding the until partition contains only one element both sides. Okay, always the pivot element is less than I and the greater than to j element. This is the condition has to be satisfied. This condition has to be satisfied. Here arrange the array and how to select the pivot element means there is no proper rule. There is no proper rule for selecting pivot element. We can select anyone as the pivot element. Okay, we'll see one example. This is the example array. In this example array, I am taking totally 9 elements. The index numbers is 0 to 8. Okay, this is the I element and this is the j element. Here we can, what is the rule for selecting pivot element? There is no proper rule. So we can take anyone as the pivot. So here I am taking the first element as the pivot. Okay, after selecting the pivot, here we have to check two conditions. What are the two conditions? Means every time we have to keep on checking two conditions. What the conditions is a of I less than or equals to pivot. Okay, less than or equals to pivot. Then what I have to do? Then we have to I value has to be increment. This is the first condition. Okay, what is the second condition is a of j greater than pivot. Then j value will be decrement. These are the second condition. We have to keep on checking these two conditions. Okay, first I am taking this is the pivot element, this is the I element. Okay, what is the first condition? A of I. So it is the I value here, I value here. Okay, then I am checking what is the value here. A of j means a of I less than pivot. Okay, here I am checking a of I is 7 less than or equals to pivot 7. The condition is true. The condition is true means what? I have to update I value. So I plus plus. So I value will be shifted here. Okay, again a of I is 6 less than or equals to pivot is 7. The condition is true. Again I plus plus. So again it goes here I value. Okay, next a of I is 10 less than or equals to 7. The condition becomes false. So the condition becomes false means we have to stop here. We have to stop here. Again we have to stop here. I have to check this second condition. What is the second condition? The second condition, a of j greater than pivot. Okay, what is the a of j value? A of j value is 7. Okay, what is the pivot value? 7. So here if you check here, that is 7 greater than 7. The condition becomes false. So the condition becomes false means I have to stop here. We have to stop here. We have to stop here there is no decrement for j value. Why? Because the condition becomes false. So we have to stop here. Now what I have to do? I have to swap a of I and j value. A of I, j value. Okay, we have to swap these two elements. Swap of a of I and j value. After swapping, what is the latest array? The latest array is 7, 6, 7, 5, 9, 2, 1, 15, 10. Okay, what is the I value? It is the I value, and this is the pivot element. And what about the j? J is, after swapping, it is the j value. Okay, swap is swap, j value here goes here, and values are changed. Okay, this is the j value location. Again, what I have to do? Again the same steps. Okay, what is the first step? A of I less than or equals to pivot, then I plus plus. Second one is A of j greater than pivot అయితే, then j minus minus. Okay, again we have to checking these two conditions. Okay, I am checking here. Please see here. A of I is less than or equals to pivot. That means what? That equals to A of I is 7, less than or equals to pivot equals to 7. The condition is true. So update I plus plus. So I value here updated. Next, A of I is 5, less than or equals to 7. Condition is true. So I incremented. So again here I. Okay, next, A of I is 9, less than or equals to 7. The condition is false. So we stop here. Okay. Next, what about the second one? A of j greater than pivot. What is A of j value here? A of j value is 10. So 10 greater than 7. The condition is true. True, I think I have to j minus minus. So j value incremented here. Okay, j value. See. Next, A of j is 15 less than 7. The condition is true. So j is incremented. So next one. So it is the latest to j value. So next, what is 1 less than 7? The condition becomes false. The condition becomes false means we have to stop here. Next, what is the next step after checking the two conditions? I have to swap the elements. What to the swapping means? Swap A of I and j element. Okay, you have to follow. Okay, after swapping, what is the array? The array is 7, 6, 7, 5, 1, 2, 9, 15, 10. Okay, here it is the pivot element. I is 1, j is 9. Okay, again what? Again we have to do same procedure. So here A of I less than or equals to pivot. That means what? 1 less than 7. I value is 1. So 1 less than 7. The condition is true. Then usually I incremented. So it is increment. Hello everyone, welcome to my YouTube channel. In today's video, I will explain the topic is merge sort in the subject of design and analysis of algorithms. Okay, what is meaning of merge sort? First of all, what is meaning of sorting means? Sorting is nothing but arranging the elements in the either ascending order or descending order is called sorting. Okay, here what is meaning of merge sort? In this merge sort, it is the one of the application of divide and conquer rule. It is the application of divide and conquer rule. Conquer. It means we have to implement this logic in this merge sort here. Okay. The next point is divide the array into subarrays. In this concept, we have to take one array of elements. These elements will be divided into two parts. Okay. This array has to divide into two parts, and again we have to implement the again divide and conquer rule here. Again it means again this array will be divided as again this array will be divided like this. and these array also will be divided. Okay, at final step again we divide it like this. Okay, after after multiple times applying the divide and conquer rule, we have to compare first array with another array. Which one is the less than, then that will be moved to first. Which one is the greater than, that will be moved to right side. Okay, same logic will be implemented up to end of the array. Okay, we will see one by one. Divide the array into subarrays and merge the subarrays. Okay, up to here we divided the array, and here we are merging the subarrays. Now array will be here when you are want to execute this term. Now array will be sorted the manner array. Finally, if you are to implement this all the steps, we will get the sorted array manner. Okay, we will see the algorithm. What is the merge sort algorithm here? Merge of sort means the I am taking the array. I am taking here algorithm name is merge sort. Here I am taking a, low, high. What is the meaning of a? A is nothing but array name, lower element, higher element. Okay, if low is less than high. Okay, when you implement this logic means if you are taking the first lower element, that should be less than to the higher element. That means what? That means you have to take the array in the sorted array. Okay, if the lower element is less than to the higher value, then only what have to implement, then only if this condition is true, we have to implement this logic. What is the logic here? It equals to low plus high by 2. It means we have to take the first element value and last element value, and we have to do the by 2 operation. Okay, it means we don't consider the element value. Actually, we have to take the index numbers. We have to consider the index values. Okay, it means 0 by 7 by 2, that equals to 4. Okay, actually this is the 3.5, so it is the 3. Okay, like that we have to consider. Next, if after finding the middle value, we have to do these three conditions. What are the three conditions means? Merge sort of a comma, low comma, mid. Okay, we have to check this one. Okay, next one, merge sort of a comma mid plus 1 equals to high. Next, a merge sort of a comma, low comma, mid comma, high. Okay, it is also when it will be executed with, for merge function we have algorithm. It is least of the merge sort. Okay, it is the for the merge sort function we have algorithm. It has the least of the merge sort. Okay, actually when you are finding this lower value, middle value, according to these two we will divide the algorithms. Okay, this is the simple merge sort algorithm. We will see one example. Okay, here what is the merge function? Here the merge function, I am writing here merge function. Actually don't confuse here, it is the merge sort algorithm. It is the merge function. It means what after dividing, what is the merge function? It is the function algorithm, function program. Okay, merge of a, low, high, mid. Okay, these are the I am taking as the parameters. Next, first of all, when you are taking the I value should be low, j value equals to mid plus 1. These are the two variables. Next, while I less than equals to mid and also j less than or equals to high. Okay, when this condition is true, then we will enter into this loop. Okay, if a of I less than or equals to a of j, it means what? It means lower bound value and upper bound value both are not less than or equals to. Okay, if this condition is true, then we will enter b of k equals to a of I. It means the b of k is nothing but is the merged element, merged array. This is the merged array. Okay, this is the final result array. Okay, here that equals to a of I. We have to take I value has to be increment. It means the first element is stored. Then again we are going for I plus plus means second element. Okay, same as well as k plus plus. Else లేకపోతే b of k equals to a of j. Second. Okay, it means left side array has to be pushed, or else right side array will be pushed. Okay, we have to store the elements either left side array a of I value or j value. Okay, it will be processed up to end of the array. Okay, next, if j greater than mid. Okay, suppose if the j value is greater than mid, then what I have to do? While j less than or equals to high, here b of k equals to a of j element. Here we have to push the a of j element. Okay, suppose this condition is false, else this condition is false, then else part is j greater than high, Here, while I less than j equals to mid and b of k equals to a of I. Okay, like this also we have to proceed. Okay, this is the midge function. Okay, we will see one live example here. We will see one live example. Here, what is the live example? Here I am taking an array is 15, 5, 24, 8, 1, 3, 6, 10. These are the live array elements. Here I am taking the index numbers 1 to 8, and here we have to take the first element as the low and last element is the high element. Okay, then we have to do what we have to do. We have to break this array into two parts. Okay, how to break? To break the array, we have to find out. We have to check the lower element is less than high or not. First one, what is the lower element is 15 is less than 20. The condition is true. The condition is true, then we have to break. Okay, so how to break? The breaking condition is mid equals to low plus high by 2. What is the mid value here? 0 by 8 by 2 equals to 4. Okay, so we have to break it this element. We have to break it this element. So after breaking, okay, this is the left side array, this is the right side array. Okay, I'm writing here method sort of a array name 0th element to 4th element, 0th element to 4th element. So I'm writing here a of 0 comma 4. Next, what about right side? Method sort of a fifth element. This is the fifth element to what is the last element? 8. Okay, this is the left side array and this side right side array. Then what I have to do? Again, we have to break this. Okay, again we have to divide these two. We have to divide two arrays. Again, we have to divide these two arrays. How to divide? Again, we have to find out the middle element. So here, middle equals to, wait, here, middle equals to 0 plus 4 by 2 equals to 2. Here, what about middle equals to? Middle equals to 5 by 8 equals to 5 by 8, sorry, 5 plus 8 by 2 equals to, what is the value here? The value is 6. Okay, here value 2. So what means here we have to divide the array. How to divide? 0, 1, 2. Okay, and here what is the right side array? 3, 4. It means 15, 5, 24, 8, 1. This is the left side array. And what about right side array? This will be broken here 5, 6. And what about this one? 10, 20. Okay, again, if you are breaking this one, what happened here? It becomes what? It becomes array of 0 to 2. What about this one? Array of 3 to 4. And what about this one? Array of 5 comma 6. This one array of 7 comma 8. Okay, it becomes like. Then what is the next step? Again we have to divide. Again we have to divide up to end of the array. Again we have to divide the array. Again we have to divide the array means because what? Again we have to find out this one. Middle equals to 0 by 2 equals to 2, that equals to 1. So we have to divide the array is 0, 1, this 2. Okay, this one. And what about this one? If you can simply divide this one, 8 and 1. 8 and 1. Sorry, here we have to write 15, 5, 24. 15, 5, 24. Here 8 and 1. Again, what about these two? If you divide this one, here what happened? It is 3, 6, it is 10 and 20. The array is divided. Okay, again we have to divide this one. Again we have to divide this one. Simply if we divide this one, 15, 5, here 24, 8, 1, 3, 6, 1, 10. Now check. Now all the elements is divided as a single elements. The now array is divided into multiple subparts. Now what I have to do? Now we have done with dividing the array elements into number of subarrays. Okay, we have divided all the subarrays. Next, now our task is merge these all the elements. What is the task? You have to merge these all the elements. Next, which element is the lower one? We place first. Okay, among this left side and right side. Okay, separately, which element is among these all? Which one is the less than? We have to put left side, and that same thing right side also. Which one is the less element? They have to put the right side. Okay, how to put? Okay, see here by comparing these two. Okay, by comparing these two, 5, 15. That is the first step. And what about here? 1, 8. And what about here? 3, 16. This is 16, sorry, this is 16. 3, 16. And what about here? 10, 20. Okay, 10, 20. Again, same. We have to put the lower value at the left side. Okay, again, what is the after these two? We have to consider this one. So, 15, 5, 15, 24. And here, same. Okay, next. Among these two, we are merging these two. If you are merging these two, what happened? 1, 5, 8, 15, 24. Okay, why it becomes means the lesser value have to put the left side. So by according to this array and this array. So first is less value. So 1, 5, 8, 15, 24. Same. If you are merging these two, then what happened? The array is 3, 10, 16, 20. Okay. So it is the left side subarray. And what about this one? Right side subarray. Okay, so we will call it is the L of I. It is the R of I. Okay, now what have to do? Now again we have to match these two arrays. Again we need to match these two arrays. Okay, what to do? Again, when we are matching these two, we have to compare L of I value and R of j. If it is L of I value is lesser than R of I j value, we have to match these two. Okay. The first two we have to compare L of I and R of j. Then which is smaller, that goes to array of B. Okay. Here I am writing B of K array. This is the final array. Okay. What I have to do here? We have to compare L of I element with R of j. Which one is the lesser value, that will goes to the array. Okay, first here I have to take in 1, 3. We are comparing these 3. Which one is the lesser value? This is the lesser value. So, first is 1. Next, it is completed. Next, 5. 5 with 3. Which one is the lesser value? 3. So, 3. Next, move here. Next, 5 and 10. Which one is the lesser value? 5. So, 5. Next one. So it is moves here 8. 8 and 10. Which one is the lesser value? 8. So 8. Next it goes to the here 15 and 10. Which one is the lesser value? 10. Okay, so it goes here 10 is here. Next one 15 and 16. Which one is the lesser value? 15. 15 is completed. Next one we are going here. Next 24 and 16. Which one is the lesser value? 16. Next one it goes here. Next here 20 and 24. Which one is the lesser value? 20. So final value is this is the 24. Next this is the sorted array. This is the sorted array. This is the about merge sort. This is about the merge sort. And what about this merge sort function means? This is the merge sort function means how we are merging these elements. Okay, this how we are merging these elements here. How we are merging these subarrays into a single array. And finally, left side array, right side array, how we are merging means that is the logic is available in this merge function program. Okay, I am stopping here. This is about our merge sort program. Okay, we will see next class. Okay, thank you everyone. Please subscribe our YouTube channel. If you have any doubts, you can ping me in comment section. Thank you everyone. Hello everyone. Welcome to my YouTube channel. In today's video, I will explain the topic Strassen matrix multiplication in the subject of design and analysis of algorithms. Okay, we will see what is Strassen matrix multiplication. Okay, it is useful in only square matrix. Okay, it is the mathematics problem. It is mainly used for solving the square matrix. What is the meaning of square matrix means? It is 2 into 2. If you take two elements, it forms the square. Same like that, 4 into 4 matrices. Okay, and 8 into 8 matrices. Like this, it is only useful for only square matrices. Okay, next one. It flows divide and conquer algorithm. Here, what meaning of divide and conquer means it is the one of the application of Strassen is one of the application of divide and conquer rule problem. Sorry, divide and conquer rule algorithm. Okay, here what is meaning of square roots? Okay, square means a of, if you take a of one element, second element. So say two rows and two columns. Same like that, 3b, two rows and two columns. Okay, if you perform multiplication is between these two, what we will get? We will get C matrix. The elements are C11, C12, C21, C22. Okay, what about this one? C is the result of A and B, that equals to C. If you multiply these two, we will get this one. Okay, if 2 into 2 or 3 into 3, easy to perform matrix multiplication. But in order to increase its complexity, to perform methods, matrix multiplication, so Strassen matrix as the developed. Okay, for example, to calculate C11, what is the formula here? We have to take row and column. What is the first one? A11 into B11. So A11 into B11 plus A12 with B21. Okay, this is the C1 value. Same like that, C22 value is A11 with B12, sorry, B21 plus A12 with B22. Sorry, this is the B12 and B22. Same like that. C2, it means second row, first column, later second row, second column. Okay, like this we have to perform general matrix multiplication. And we will see what is the Strassen matrix multiplication. Okay, in Strassen matrix multiplication, suppose if you, this will be useful. This way we can multiply only 2 into 2 matrices and 3 into 3 matrices. For example, if you get the problem, multiply 4 into 4, what is the solution? Okay, if you get a question like 4 into 4 matrices, what is the solution? Okay, we don't know. What is the 4 into 4 matrices? We have to follow Strassen matrix multiplication. Okay, suppose this is the 4 into 4 matrices, 4 into 4 matrices, and it is also another 4 into 4 matrices. Okay, it is the A matrix, it is the B matrix. How to multiply these two? Okay, how to multiply these two? Okay, to multiply 4 into 4 or more than any square matrices, we have to use Strassen matrix multiplication formula. Okay, here what it is the one of the operation of divide and conquer. What is the meaning of divide and conquer? Divide and conquer means we have to break the problem into small problem. Same as here also. This is the A array and B array. It has to break into small parts. Okay, how to break? Okay, we need to find the mid value to break this one. Okay, so for example, what is the value? Here the value is 4. So 4 by 2 equals to 2. So we have to break this one 2 into 2 matrices like this. We have to break like this. Okay, here this is the first matrix, second matrix, third matrix and fourth matrix. We will treat this is the entire matrix as A11. And what about this one? This entire matrix is treated as the A12. And this is the A21 and this is the A22 matrices. And same like that, B matrix also will be divided into 4 parts. This is the B11, B12, B21, B22 matrices. Okay, and now after that we are breaking it into 2 into 2 matrices. Now after breaking this, what I have to do after breaking this, we multiply directly assigning by 2 into 2. Assigning by 2 into 2 for these matrices. Okay, After breaking, we have to multiply with each 2 into matrix with another 2 into 2. Okay, like this we have to multiply this all the values. Okay, we will see what is the matrix, what is the matrix multiplication program. What is the matrix multiplication algorithm? Here is the matrix multiplication algorithm. Here the matrix multiplication algorithm. Here I am taking A matrix, B matrix, N value. Okay, A, B are the A matrix, B matrix, N is the order of the N matrix. Order of the N matrix, and order of the N means what? 2. Okay, suppose if N, what is the condition we have to check to apply this Strassen means if N less than or equals to 2, then only it will be allows. Okay, sorry, then it is the general matrix multiplication. Okay, if it is N equals to less than or equals to 2, it means it is okay. Okay, if it is like this means general, these are the general matrix multiplication steps. General matrix multiplication steps. Okay, what is the general matrix multiplication steps? These are the general methods. What is the general methods? Okay, we will apply these common rules. Okay, before, suppose if N value equals to 2, we will follow general method. Okay, else if suppose this condition is false, then what happened? Then here else part. What is else part? Else part, what is I have to do? Else we have to find out the middle value. What is the N value? Suppose N value 4 means N middle equals to N 4 by 2 equals to 2. Like that, we have to split this one. How to split? See, how to divide this matrix means matrix multiplication of A11 comma B11 comma N by 2. So we have to take this entire part. We have to take entire A11 comma B11 by 2 plus same general matrix multiplication only. Okay, plus of A12 comma B21 row and column. So row A11 into B11 B21 by N by 2. Same like that. For this is the first A11 matrix. This is the A12 matrix. This is the A21 C11 matrix, C12 matrix, C21 matrix, C22 matrix. Okay, we have to write this matrix. Okay, if you have to multiply this, we will get the resultant matrices. Okay, and what is the formula for this one? What is the Strassen matrices means? Okay, after dividing that, we have to calculate. After dividing the matrix, we have to calculate some formulas. What is the formula means? P value. We have to calculate the P values. These are the 7 formulas in Strassen matrix multiplication. What are the 7 formulas means? P value you have to find out. Q, R, S, T, U, V. These are 7 formulas we have to remember. Now, what is the final resultant matrix? The final resultant matrix are C11, C12, C21, C22. So, what is the value? To get C11 value, we have to add P plus S minus T minus V. That is the C value. And what about C11 value? Is if you add R plus T, that is the C12 value. And what about C21 value equals to Q plus S, that is the C21 value. And what about C22 value is P plus R minus Q plus U. Okay, if you add these elements, we will get this result. And what about this? According to these all values. Okay, like this, if you add this all value, we will get the final resultant value. Okay, by using these 7 formulas, we have to go into find out the regular matrix of C. Regular matrix of C. Okay, what is C is? C of C11, C12, C21, C22. Okay, how to get these values? By adding these elements. What is the advantage by using Strassen matrix means? If you use this method, we can reduce the 1 unit of time, 1 unit of time by comparing regular way to perform matrix multiplication. Okay, thank you everyone. This is about today's class. If you have any doubts, you can ask me in comment section. Okay. If you like our video, please like and subscribe. If you want any important questions, any requested topics, please post in YouTube channel comment section. I will surely make a video for that required topics also. Okay. Thank you everyone. Thank you. Bye.